Hi, hello, my name is Kiran Kumar. I am your physics lecturer. Today topic is interference of the wave. Welcome to my channel Nature of Physics and Art. Please watch my previous videos. See, considering two sources S1 and S2. Y1 is the displacement of the first wave from point P to S1 and Y2 is the displacement of the wave from P to S2. Here first wave reached the point P, then second wave reach. Reason is due to the path difference there is a phase difference, that is constant initial phase difference. Okay, that's why we will write here first wave displacement equation A1 sine kx minus omega t and second wave displacement equation A2 sine kx minus omega t plus phi. Okay, here phi is the phase difference. Okay, the phenomena of superposition of two waves of equal frequency moving in same direction in a same medium is called interference of the waves. Okay, so two waves displacements are completed here. So then law of superposition equation, that is y is equal to y1 plus y2. Then here y which is equal to a1 sine kx minus omega t, a2 sine kx minus omega t plus phi. See here y which is equal to a1 sine kx minus omega t and a2 sine a plus b formula sine kx minus omega t cos phi plus cos kx minus omega t sine phi. Okay, see here y which is equal to sine kx minus omega t is common, then remaining value is a1 plus a2 cos phi and remaining value is a2 cos kx minus omega t into sine phi. Rearranging the equation, before that the values are here a1 plus a2 cos cos phi which is equal to a cos theta is the resultant amplitude. Okay, so a2 sine phi which is equal to a sine theta, this is taken as equation 1 and equation 2, both are replacing in the above equation. Then the resultant equation y which is equal to a sine kx minus omega t cos theta plus a cos omega t minus kx into sine theta after replacing the values. Then this equation is y is equal to a sine kx minus omega t plus theta. So this equation represent as equation 3. Equation 3 represent the interference of the wave. Please copy this. We did a resultant equation. That equation represent the interference of the waves. From equation 1 and 2 we will get the resultant amplitude. See here, A is the resultant amplitude from A1 and A2. A1 and A2 acting as a two adjacent sides of the parallelogram. A represent the resultant, that is diagonal of the parallelogram. So equation 1 and equation 2. See here, equation 1 square plus equation 2 square. See, that is first A square cos square theta plus A square sin square theta LHS side values, which is equal to RHS side value A1 square plus A2 square sin square cos square phi plus 2A1 A2 cos phi plus A2 square sin square phi. See here, A square is common and sin square theta plus cos square theta is 1, which is equal to A1 square plus A2 square cos square plus sin square phi is equal to 1 plus 2A1 A2 cos phi here. Okay, so A is the resultant amplitude, that is root over A1 square plus A2 square plus 2A1 A2 cos phi. This is taken as equation number 4. Equation 4 represent the magnitude of the waves, and then we will do the direction from equation 1 and 2 only. Now here I am writing equation 2 divided by equation 1. See now, equation 2 value is A sin theta divided by A cos theta, which is equal to A2 sin phi divided by A1 plus A2 cos phi. Here A get cancelled, then sin theta by cos theta is tan theta, which is equal to A2 sin phi divided by A1 plus A2 cos phi. So this is taken as equation number 5. Equation 5 represent the direction of the waves. Please copy this. Now continuation, we got already resultant amplitude equation. A, which is equal to root over A1 square plus A2 square plus 2A1 A2 cos phi. See now here, if A1 is equal to A2 is equal to A, see, then what will happen? We have to discuss. This is a resultant amplitude AR I am writing. So here AR, which is equal to root over A square plus 2 A square cos phi. So then AR, which is equal to root over, tell me, that is 2A square plus 2A square cos phi. So AR, which is equal to root over A square plus A square is here. We can take A square is common, that is A square is common, then the resultant equation is 2A square common, 2A square common, that is 1 plus cos phi. Okay, so then AR, which is equal to root over 2A square, 1 plus cos phi value is 2 cos square phi by 2. So then AR, which is equal to root over, tell me, 4A square cos square phi by 2, and AR, which is equal to 2A cos phi by 2 is the resultant amplitude if A1 is equal to A2 is equal to A. Please copy this. Intensity at a point of interference. See, already we did in one video that relation between the intensity and amplitude. So here intensity I is directly proportional to the amplitude square. amplitude square. Okay, so then we can write simply, that is I is directly proportional to the a square. Okay, from the above equation here, a square which is equal to a1 square plus a2 square plus 2a1 a2 cos phi. Here I1 directly proportional to a1 square and I2 is directly proportional to the a2 square. So the resultant equation is I, which is equal to I1 plus I2 plus 2 root over I1 I2 into cos phi. See, we can write here a is directly proportional to root I1 A1 and A2 is directly proportional to root I2. See, then the values are replaced. This equation represent intensity at a point of interference of the waves at a point P. See, please copy this. We did relation, interference equation and also amplitude of the waves. Now we will discuss the interference is classified into two types. One is constructive interference, another one is destructive interference. See, when constructive interference will be formed and when destructive interference will be formed, we will discuss step by step. For this, here S1 and S2 both sources are taken as the coherent source in which frequency phase is remaining same for the both sources S1 and S2, then only that should be a coherent source. See here, for constructive interference, first wave crest, second wave crest overlapping, and first wave trough, second wave trough also overlapping because of same phase for the both crest and both troughs. That's why amplitude is maximum, then intensity also maximum because of same phase. Whereas in destructive interference, here first wave crest, second wave trough overlapping. That's why both have the opposite phase. Whenever phase is opposite and amplitude is minimum because of positive amplitude, negative amplitude, net amplitude is minimum, that is 0. Here also we can take one trough and crest overlapping. That's why opposite phase, then amplitude is minimum, intensity also minimum. In the constructive interference, we will get maximum amplitude, and in destructive interference, we will get minimum amplitude. Try to understand step by step. See here, the condition for the constructive interference, phi is equal to pi n, where n is equal to 0, 1, 2, 3 up to so on. So here cos phi, which is equal to 1, for example here n is equal 0 taken, here phi is equal 0 and cos 0 is equal to 1, here cos 0 is equal to 1. Then the resultant equation A, which is equal to a1 square plus a2 square plus 2 into a1 a2 into 1, this is a root over. See, continuation A, which is equal to root over a1 plus a2 whole square root get cancelled. So here A amplitude is maximum, that is a1 plus a2. Try to understand. In destructive interference, phi is equal to n plus 1 into pi, where n is equal 0, 1, 2, 3 up to so on. See here cos phi, which is equal to -1. Reason is 0 replaced here, 0 into anything 0, that is pi cos pi 180 degrees is minus 1. So we can write here a, which is equal to root over a1 square plus a2 square, okay, minus 2a1 a2. Okay, simply here cos phi, which is equal to minus 1. See, a, which is equal to root over a1 minus a2 whole square root of cancel. Here amplitude is minimum, that is equal to a1 minus a2. Okay, if a1 is equal to a2, then here maximum amplitude A max, which is equal to 2a. Here if a1 is equal to a2, okay, which is equal to a, then we can write here minimum amplitude, which is equal to 0. Here a1 is equal to a2 is equal to a, I am writing here, that's why a plus a is 2a. Please copy. Just now completed amplitude is maximum in the constructive interference and amplitude is minimum in the destructive interference. Now we will discuss intensity also. The intensity of the interference at a point of intersection, there also we will get maximum intensity and minimum intensity. So we will get constructive interference is maximum intensity and destructive interference is minimum intensity. The reason is in constructive interference amplitude is maximum. Whenever amplitude is maximum, intensity also maximum. In destructive interference intensity is minimum, reason is amplitude is minimum. See, we can do here cos phi, which is equal to 1. For the constructive interference, I is equal to I1 plus I2, okay, plus 2 into root over I1 and I2. So then I, which is equal to, okay, we can write intensity is maximum, so that is maximum intensity here. Then next equation, that intensity I, which is equal to I1 plus I2. Here cos phi is minus 1 for the destructive interference, minus 2 I1 I2 root over, then here intensity is minimum, so here intensity is minimum. Already we did amplitude relation in the constructive interference and also destructive interference. We will discuss with intensity. See, now first one is amplitude is maximum, which is equal to a1 plus a2. Here intensity is directly proportional to the amplitude square. Then we can write here amplitude maximum whole square, which is equal to a1 plus a2 whole square. Then here intensity is maximum, which is equal to, that is a1 plus a2 whole square. See, amplitude maximum, intensity also maximum. See, and also here amplitude is minimum, how much, which is a1 minus a2. So intensity is directly proportional to the amplitude square, then a minimum square, which is equal to a1 minus a2 whole square, that is I minimum, which is equal to a1 minus a2 whole square. Please copy this. This is the last relation in the interference of the wave. Here, based on the phase difference, we will find the path difference in the constructive interference along with destructive interference. Try to understand step by step. See, here phase difference delta phi, which is equal to pi by lambda into delta x. From this we can write path difference delta x is equal lambda divided by 2 pi into delta phi. See, delta x, which is equal to lambda divided by 2 pi into delta phi value is 2 pi into n. So here 2 pi is get cancelled. So then delta x, which is equal to n lambda. See now, and continuation here delta x, which is equal to lambda divided by 2 pi and delta phi value is 2n plus 1 into pi. Here pi get cancelled. So delta x we can write as here 2n plus 1 into lambda divided by 2. Here the values are, we can replace delta x value, which is equal to n is equal 0 0, and next one is lambda, next one is 2 lambda, 3 lambda, up to so on n lambda. Here we will get delta x, which is equal to here n is equal 0 lambda by 2, and next one here n is equal to 1. Then we can write this is 3 lambda by 2, and next 5 lambda by 2 up to so on 2n plus 1 1 by 2 lambda by 2. This is the relation in the interference for the constructive interference and destructive interference. Please copy this. Thank you.